Okay, again, welcome to Netpedia. This is our day 4 class. And day 4 class, and this was a chapter that we are still we are reading, and we still going through the chapter is Introduction to Networking Basics and Devices. And this is a customized course and customized chapter that a little advanced than what you studied in CCNA earlier, or may not, but this is a pretty different that we are trying to achieve here. So we did some customizable devices. We did some efforts to improve Cisco's course understandability, so where the people can understand how devices and everything works rather than just go through the PDF. So we try to go through videos and pictures and trying to put some PPTs and everything, which will help you to increase your understanding on, and even the ease of the understanding on the devices, especially because the devices makes a major role in the industry, and that has to be cleared with the concept within the motherboard towards the outer software board. So you should understand everything clearly, that okay, what is actually a devices, what actually those networking devices do. So let's read about the devices. So type of devices and networkings are we criteria into three type of devices. Most probably it's like 10 type of devices, but mainly what we're going to study in CCNA, it's only 3 type of devices. The first is WAN devices. The WAN devices are router, which could be Cisco router, FortiGate router, any kind of brand. It doesn't need to be just only Cisco, but we are studying right now Cisco CCNA certification, so we recommend to have Cisco. So Cisco router would be here. WAN switch. So there are some special WAN switches are available nowadays from Netgear, from Cisco, from there is another company, Microtik. They are very great in that, and they have they are actually very great in the WAN switches. And then we have, I think last time we heard about when we were doing our introduction classes, when we had that Netpedia's presentation PPT, which is telling about what is Netpedia. So we learned about Arista, Aruba, Ruckus, and all those, right? And Juniper. So those are actually a one ISP, or you can say those are main stream of type of modems and WAN switches and router. So then we have MUX. And edge gateway works the same, but little different from router. They are mainly connectivity from your ISP to just for their router. So they work in between somewhere. They're not really a router, but they work as a router, slightly different. Then we have a fiber. So if you have a fiber, it's a fiber MUX. Then if it's an edge gateway, the fiber edge gateway. So it depends on what kind of, if you're using a Ethernet copper cable, so that would be a copper MUX and copper edge gateway. And if you have a fiber MUX and fiber edge gateway, so it will be fiber. Then we have a LAN devices. LAN devices that I've been in the last meeting and the last lecture, we talk about what is LAN devices. So LAN devices are the one who they are responsible for what? For the internal communication. Let's say you have internal share file devices, internal computers, internal access point, internal devices, that servers, internal APC units, whatever they need to be communicate with each other, they all call what? LAN devices. So mainly when you have a LAN devices, so you must have switches. Switches could be layer 3, layer 2, any kind of. So switches are the one who are responsible for doing all kind of LAN devices, LAN interconnectivity or LAN operations. Then we have a hub. It could be repeater. It could be active ones. We will see in the next video when we play with that. So we will see what is hub, what is repeater, what is active ones, and what is passive ones. Then we have access control point and controller. So access point is pretty same as Wi-Fi devices. Those are actually give communication to Wi-Fi device. If you have a laptop, if you have a phone, you want to connect to the Wi-Fi, and you have a big building of 200 people or 2,000 square feet building, so you cannot put so many modems, right? You cannot buy so many internet. So what do? You buy APs, access point, from any company. I'll show you in next slides too what is AP look like, how the access point and controller look like. We'll surely show that. Then we have one of the major stuff today is in the market, which is really need to be studied by every network engineer, every IT system administrator, everybody, even not for those, even some people who are not really sure about what is IT, they must know what is security. Security is not really, just a physical. It has to be, nowadays, it's more software as well. So how to achieve with that software? That is called, we have a antivirus used to be, right? So we used to have antivirus. Let me bring my pen so we can understand more quickly on this. Okay, so we used to have, when we buy a new laptop or buy a new computer, right? Buy a new laptop or buy a new computer, what we do? We put antivirus inside, right? Antivirus. Why? To make sure nobody breach our computer. No one breach our computer. Breach in the sense, nobody use our computer without our permission. Through remotely, not through physically, but remotely. Physically, yes, still people can do that if you do not put the password. So yes, still people can use it, right? And I'm just gonna switch my color. So if you can have an antivirus, so but you cannot put you cannot put antivirus in whole network, right? Can you? Let's say your switches, your AP, and your whole network. Whole network. Would you be able to sorry, spelling mistake. Would you be able to do that? Anybody wants to answer yes, no? Would you be able to put an antivirus in the whole network? Like software? Yes or no in the chat? Anybody? Mukari, Chaitanya? Anybody? Okay. No, okay, that's good. Thank you. That's a good answer. Yes. Yes, Justin, that's good. That's a really nice answer. Okay, so what we need to do then? So we need to have some sort of device. A device. It's called what? Firewall. It has to stay somewhere before your internet. Let's say you have one router gateway here, and you have inside LAN, like there's a switch here, right? And all your computers connected here. So your firewall will stay here. This is your firewall. This is a best practice. You can put inside too. Some people, they try to put firewall inside too. Then I will show you in our upcoming classes why we put firewall inside. This is called what? Transparent firewall. And this is just edge firewall. Some people put two firewalls, one for inside, one for two. That's what we did in our company. We put one firewall at the edge, one firewall for LAN inside. Some people do that. It's good if you have enough money. Your company is allowing you to put some budget, so it's okay. So then we have two types: intrusion detection system, and there are two types of firewalls. And actually, two kind of operations what the firewall do. Two kind of operations. Operation that firewall do. What is that? Intrusion detection system means like anything happened to your network, so it will just detect it. And then the same log will go to prevention system. One of the other device will prevent it. That's pretty simple. Alarm and prevent it. Then we have an NGFW firewall, which is really important. This is the latest firewall. So far we're using since 2017. This came up, next generation firewalls. Palo Alto, the one I told you in the earlier classes, that Palo Alto is the one who's leading this market, then FortiGate, and then going through the Cisco and all others. So these are the very great ones you can buy if your company wants to. So you can buy any of these firewalls. So a next generation firewall it has a way more advanced than these legacy intrusion. It has IPS IDS inside too, and it has what? Layer 7 filtering too, which is say that it actually can stop application too. Layer 7 means like application filter here inside. You can actually tell how application working, and you can stop certain thing of application firewall call. Then we have a virtual VPN constructor. You can do same thing on NGFW, and even you can make on router as well. You can same thing do, but some people don't want to spend money on firewalls. Well, what they do, they just buy a VPN concentrator, a small device, which just make VPN for you, just a secure communication. So VPN is what? Virtual private network. It means if you have two branches, one here, two here, so you want to have a secure channel over the internet. It's over the internet. ISP 1, ISP 2. So you can make some tunnels which will provide a secure tunnel, like secure pathway or secure traffic encryption between two branches with two routers or whatever the VPN concentrator you're using. So that's the different. I'll show you in the next classes what does that look like when we go for VPN thing. We will read this again and again. We will learn this again and again. I'm not gonna keep it just one time and then do not repeat it. I'll repeat it again and again. So make sure you have been in touch with everything, because our classes are like once a week. So, and then we have a load balancer, right? What the load balancer are? Like load balancer are pretty simple. Anything balance with the things. Let's say you have two servers here, S1, you have S2, right? And they have any kind of shared drive, like shared file system or like shared drive here. And you have one user one here, right? And then you have a user two here, right? And then what they want to do, they want to access this guy and he wants to access this server, or like simultaneously they want to use this server. So what happened? Server will be confused, right? You cannot do the shared out. So what you good? You put load balancer here, and this load balancer have a cable here, and you connect to this here. Then let me just make a little mess back. Sorry, this looks like a little more mess for you guys. Sorry. Okay, so okay, that's much better. Hopefully, but anyway, we're gonna learn it again. So we just a small introduction. And user two here. So what's gonna happen? Okay, user two and user one will request to this load balancer. It will automatically, switch the way of the. Okay, it will keep connecting with talking to server one and server two, and it will ask, okay, what's your status? Are you okay to receive more traffic? It will say yes. Okay, then this will go automatically here. So this is good for VPN as well. You can use load balancer for anything. It's not just for servers. You can use for anything. When we will learn more in deep when we go. So there are F5 big IP. This is leader market in the leader. Then we have HA proxy. This is another software-based load balancer. And then we have Nginx. Nginx is just a web server, which does some sort of load balancing. Yes, it does actually. Then we have an application delivery control, which is more like let's say when you have any kind of application that we need to know what is and how the traffic and SQL of working, how our traffic is being, receiving from application to user. It actually does. This kind of, devices use it, but really you will see that not really often. It's on a bigger company, bigger scale people. Well, we will discuss later. But this is another device from the aspect of load balancer. Any questions so far? And I'm going so fast. Is there anything you want to slow down or something? Chaitanya, Bukhari, Vikas, anybody of you? Any problem to understand anything so far? Justin is okay. Okay, great. Okay, then we have type of switches. Type of switches in networking, most important part. And anybody tell me where we use the switches in our networking? Where we use switches? Where we use switches? Anybody? Chat or unmute. Where we use switches? Because you too. Justin, you too. Somebody texted back. LAN, that's great. That's great, Justin. Good to hear. At least people are focusing here. That's great. Nice. Okay. So typically switch use where? Like mainstream. Like if we ask for general purpose of switch, it should be connectivity of what? Your LAN side. You can use it for anything. You can even use for WAN too, but that's not a good practice, right? But some people use it for, let's say you have a multiple ISP, so you can use, but we will discuss it later. I'm just, telling you it's not, I'm not gonna teach you wrong. So there is a lot of ways you can work around with switches, but mainly you use it for LAN, yes. And then we used to have bridge switch, which is outdated now, no more in use, but we still will be touch and base with it. Some maybe old companies still are using bridge switch, and you will go to a very old warehouse they hire for your networking, and or you work as a contractor when you go there, so you may understand or may need to understand what you do bridge switch. It was very exciting when it comes to the market. Honestly, bridge switch can bring the okay. So new nowadays, what are the switches we are seeing now? Those are the what? Those are the son and daughter of what the latest switches. Sorry, the old switch, the bridge switch. So if you see the Cisco switch or any kind of switch, they work on the same concept the bridge switch used to work. But bridge switch used to be on the software base. So it used to be very slow. It was a software based. So a computer used to be here. That computer used to have a software, right? A GUI software used to be here. Then a switch used to connect to that computer. And then any computer that connected that switch, first switch used to send data to computer software and where I need to send the traffic. So then it used to work like that. Still some legacy Linux system works on same process, but it used to be very slow. So just because of that, because it works on software thing, it's a very kind of and today's switch are completely ASIC based. I'll show you what is ASIC as well, but in the next upcoming slides. It has to be now. What about that? And
Excuse
unmanaged.
me, sir. Sir,
Go ahead. Who's that?
excuse me, sir.
Yes, yes.
Sir, can you please define a bridge switch again?
Okay, bridge switch. Great. Okay.
Yes, sir. It is
Bridge
like a
switch is
microphone.
your company is using right now?
Yes, ma'am. Yes, sir.
Okay, so bridge switch is used to be, it's pretty legacy, pretty old. So this is a switch here, like 4 ports or 5, 6 ports. Then you have a computer here, a server or a computer, a big server, and
Okay, sir.
it has a software inside, GUI, some software inside, right? Some software. That software control that switch
Oh, okay,
completely.
sir.
Yeah, it doesn't be controlled. Nowadays, switches are controlled by themselves. There is no external server you need to be control those switches. So you've been controlled by here. So let's say here two computer laptops are connected to that switch. So what happened when you send a traffic? First, it will go to the server, and server will tell you where you have to switch the traffic between here or there where. So it used to be very slow. Let's say you'd send a traffic, it takes like some sort of time just to process it, right? So that's why we're not using bridge switch anymore. But some companies, you will say, let's say if some companies warehouse is 90, 60 or 70, 80 built, and they never made their network topology has been changed, or they kept it working, they just changed their wires, never their infrastructure. So you may see these kind of switches there. You may. Not really, not necessarily. Like everybody's like, switches are really not really expensive nowadays. You can find $100 one switch.
Thank you. Thank you so much.
Yeah, okay, no problem. Right? So there are unmanaged switch. Unmanaged switch are what? It's pretty simple. So these switches are work as switches, but these are unmanaged. You cannot do anything. You cannot change anything here. It's a plug and play switch. Let's say you connected to one device here, right? You connected to one device here. Let's say unmanaged switch are here. You could say unmanaged switch. This is UMS, like unmanaged switch. Then you have two computers are connected here. One computer here, one here. So traffic flow here, like any packet you send or anything, any frame you send from here. So this unmanaged, you don't need to configure anything. You don't need to configure anything here. It just automatically receive traffic and will start sending traffic, but it will send only traffic to which port is connected. So hub, we so far we have to go for hub right now. We want to see some video where how hub work, right? But still, this is just a basic understanding how a switch and managed switch works. Let's move down, and we'll stop here on managed switch because it's gonna be confusing for you. So I'm gonna put a little stop here. We will watch a one video that we create a one small animation for you to understand. Let's start with that, and that should. So here is that. So there are three things here. Everybody can see that? There is a one video screen.
Yes, sir.
Okay, so what is that? This is a hub. This is a router, right? This is what? Switch. Okay, that's great. So we have a router, switch, and hub. And let's go for an next if it's turned on. And you can see the link lights, how it works. You know, I showed you in the last time we met. So I showed you what is a link light and what's the fault you could have if you have link lights off or on. So if link lights are up, it means it's connected and it's working. So it's just an animation. It's not really a live demo. So here is the hub. So what is showing right now when you connect in cable? So you connected one cable here, and what is the connect cables are coming from? Anybody tell me, like what the cables are coming from right now? What are these cables are coming from? Anybody can explain? Like you can just say in the chat as well. What are these cables are coming from? From where? From what are the source of these cables? What are the source of these cables? Anybody?
Sir, switchers.
Yes, but mostly what you could call it, end devices.
Endpoint device.
Endpoint device, great. So these are endpoints. Endpoints may what mostly endpoint have to have networking. One is MAC address. This is a parameters where we connect to the world, and another is IP address. These two things, right? These are two parameters that how you're connecting to the network, to the world. We are running out of time for sure. Anyway, we will join again back. So these are end devices. This is the source endpoints, and these are source, like same endpoint. There are some computers. You would say endpoints what are computers. So it detected right away. Hey, I detected one. I detected one. I detected one. It whatever detect. So it may detect switch as well, whatever it detect. So then what happened? What really happened when you do that? When MNS detect? Let's see in the next slide, in next videos, next 5 seconds, what it does for us. So a link goes active right away. Link goes active right away. In the slides, where you can see link goes right away. So when you receive and traffic, so let's say we open the cover and what you see that here. Anybody can see like this is the cover is open and there is a yellow and kind of transistors are inside and a little board here, which is Ethernet board. And when you receive a packet from this computer and it's sent to everybody, what happened? When you receive a traffic, from here, this is the point, or here, or we receive a traffic from here to here, right? Whatever the traffic you receive, what it does, it comes to there. You call it not a very intelligent, not a very, or you can not a very smart switch. These are what? Just basic wires connected to each other. Let's say you can connect the cables by themselves too, but you need some sort of interface, right, to connect the cables to each other. So what it does, when you receive a cable, receive a signal or packet, anything, if you receive it here, it doesn't know where to send. It will send to everybody, which is a bad thing in the network, right? If you send packets to everybody in the network, what will happen? Anybody?
Collision domains.
Yeah, it will happen. What? Collision. What will happen? What collision means? Collision domains. What does that mean? It means you may have a traffic coming from this side as well. It could be traffic are coming from this side as well. Then how you would do that? So when this happen, so there could be a problem. So it could be that your data could be corrupt right away, or you may not receive the data just because you have a two-way bidirectional traffic coming off. So that's why hubs are not really recommended. Hubs are at a very worst case scenarios. You use hubs. Hubs are what? At very worst case scenarios, when you have just only 2-3 devices. Let's say somewhere in the networking company, if you're running a networking company or you have a big here warehouse you're running, you have bunch of switches here, bunch of switches here, here, and you have around here just one device is connected here. But it's more than what? It's more than the length of the cable. Maybe you can only use what? 300 feet RJ45 cable, right? You can only use that much cable, right? So you cannot extend the 300 feet. So what you can do, okay, you after 300 feet, you can put one hub here, a hub, then hub here, and then you may just have 1 or 2 computers here or a printer here, so you can connect it here. So hubs at that kind of scenarios. You do not put hub directly to servers or something like that. You do not do that. It's not a good practice. So that's why we don't use hub that often. So hubs could be many type, right? Hubs could be what? Repeater, which is right now working. Repeater at what? This is a repeater hub right now, it shows. So what happened? Let's say you drive near here, it will repeat to all. This is called what? Repeater. That's simple. Any questions, any confusion between hub to know what the hub's operations are? What is data and how data is been traveling? Is anything, Chaitanya, Justin, everybody? Because any confusion so far?
Sir, I have a doubt.
Okay, go ahead.
Why hub is used?
Yeah, well, hub is used in very worst case scenarios. Worst case scenarios. Let's say in last picture I showed you, okay, let's say you have a one big warehouse, this warehouse, right? And you have a IT rack is here, right? You have an IT rack here. Let's say you have one IT rack here, right? So what you're gonna do, you're gonna let's say you have one. So what you could do with the RJ45 Ethernet cable, right? Ethernet cable, it's only can extend up to how long? 300 feet, right? You cannot use more than 300 feet RJ45 cable, Ethernet cable, right? That's true, right? That's a true fact. So let's say your printer or one printer and user are here, which is more than 300 feet, right? Which is more than what? 300 feet. So what you're gonna do, you would run a cable and you would put one hub here, small hub, and another you will run two more, maybe 20 or 30 feet cable from here to these printers and computers. Just for these ones. Just for that, you can use switch as well, but some company don't want to spend money, right? So you can save some money just because of hub as well. So it repeat the signals.
So it connect the 2 points.
Yeah, it connects just 2 points.
Okay, sir. Thank you.
Yeah. Like you can have the switch, you can have a hub that has only 48 ports as well, not just 2. You can have a hub of 48 ports. It does not necessary that only connect 2 points. But you rarely use only 4 or 5 devices that has only been used right nowadays. So it's not a good practice to use a hub. Not a good practice. Not a really good practice. So let's move to the next slide. Somebody mute themselves, please. Okay, thank you. Okay, this is hub. See here, you would see more in understanding with the picture, with the clear diagram, which is just sharing and traffic. See here, when they receive the traffic, it's sending to everybody, right? So it's sending the traffic to everybody. That's called hub. That's a repeater thing. It's most probably a repeater. Then we have switch, and after that you will see what? A switch. See here, that's a switch. That's a switch. That's how it works. Let's say it's being blinking up, it's detecting something, it will detect something soon. And let's say what it detect. See here, you would see some MAC addresses. So when you see the hub picture, when you see the last time hub picture, let me actually change my color to black, the pen color. So it does a more, it's the white and yellow is not really a. So when you see the hub picture last time, this picture, what is this picture? Here, this picture. So you would not see the MAC address there thing. Did you see any MAC address stuff? Anybody remember the picture? Or we can go back as well. We can go back as well. See here, did we see any? No, right? Just port and device detected. But when you come here, so what do you see? You see a MAC address table as well. This is what makes a switch and a hub a very big difference. This is kind of a huge difference between a switch and hub. Hub mainly works on layer one. Layer one means you have a cable to cable connectivity. Cable to cable connectivity. You have cable, you detect it, you just say, okay, that's connected. You have a cable to cable connectivity, but switch is more smarter than the hub. Switch knows where to go. Switch knows a little bit more than hub. Switch do not, okay, let's say you send a traffic. Switch will do not send to everybody. It will only send to the person that he's connected to that. So that's what the MAC address comes. So MAC address works on layer 2. That's what the OSI model that we will be going to learn in upcoming classes, in one class, in next class, or maybe today, or maybe whenever I get a chance, maybe I'll teach you a full OSI model. And I'm trying to planning a video as well, which give you more understanding, robust understanding on, especially on how OSI layer works and which devices comes and which kind of interfaces works between and operations of OSI layer. So yes, we will surely learn on that. So did you see the big difference, right? You see like a hub thing, detected. This is the same like hub, but an extra feature here, what? Knowing the MAC address as well. Yes or no? Everybody in the chat? Clear?
Yes, sir.
Okay. Switch primarily works on what? Switch primarily works on MAC address, which is works on layer 2. So that's a between, that's you can see now. That's the now two big difference here. So one difference, you see the layer 1 OSI layer, let's say layer 1 difference, layer 1, then you have a layer 2. So that's the difference between those layers as well. So layer 1 has hub, a direct cable, right? These works on direct. So you have a just connectivity, you just repeat yourself. But layer 2, it has an extra portion here layer. This thing is layer 2, MAC address. This is layer 2 for you, buddy. Everybody. This is layer 2. This is extra portion that you have a MAC address. So switch understand MAC address thing. Switch has a small software inside, or you can say switch has so many components. Switch has so many components. Switch has a motherboard, a full motherboard. One is ASIC motherboard, which is primarily responsible for what? For physical operations, for a cable operations, ASIC is. Then we have a CPU inside, a RAM, a local firmware as well, a disk drive, everything. So switch is like a computer, you would see. Switch is not really different than a computer. Switch has everything, RAM, a firmware, a operating system, a Linux operating system, like mostly works on every switches. So it has everything. Primarily, it has everything. Primarily, it works on layer 2. It works on what? Layer 2. So when you receive a packet from here, from a computer, here, so it will not distribute to everybody. First, it will open that packet and check what is inside. A frame, what is inside. It will say, okay, I have a source, I have a destination. It will send to that space. Let's say this MAC address is here, so it will only send to this guy. It will process quick. That's what the ASIC, American Standard Internet Connectivity, that's ASIC motherboard is responsible to doing that kind of operations or transaction between traffic. That's the responsibility of ASIC. That's a very good to understand. You can even, tell yourself into when you go to the job interview, so you know what is ASIC. They will impress with you. Pretty impressed. So that's the link layer. Let's go for next. Let's open the box of that. See here, data indirected only to the intended port. data directed only to intended port and only receive and traffic. So you cannot do just repeat to everybody. Just whoever intend to have that specific data, only that will receive. More of a good as a security prospect as well, right? So you can make secure your network through your switches as well. Nobody can hack your traffic, right? Somebody will be the man in the middle. He can listen to every traffic. So that's how it's working right now. You would see here. So in the hub, it used to send everybody. When the hub was here in the hub case, it will send to everybody. But in case of switch, if it's sending a traffic and traffic says that please send to only this MAC address guy, so it will only this to this guy or this to this guy. So that's between a major difference between a layer 1 and layer 2. There's a major difference.
So it is used to share a data separate.
Used to share what? I didn't get it.
Used to share a data for individual or separate.
Yeah. So no, it's not. It's nothing with the data right now. So switches are operations. You understand just operation. You don't go for data right now. Data is same thing. Data is, and same what we are doing is the same data stuff, but you need to understand just the operation. What is operation right now? Hub primarily will repeat to everybody, right? Repeat to everybody because we just connect with the cable. Hub is just like connecting two cables together, just like same, right? You just receive a traffic sent to everybody. But switch has operation to understand what is inside a packet. It can go, so in the OSI layer, how many layers we have? We have 7 layers, right? We have application layer, we have presentation layer, or you can session layer. Then we have presentation layer, right? Then we have a transport layer, right? Transport layer. Then we have a network layer, right? Then we have data link layer, which is a Matt Tracker is right now seeing. Then we have a physical layer, right? So we have these 7 layers right now. That's how we understand virtually our network. That's how we understand our network. I'll make a separate video on that, and I'll share with you a full fledged of OSI layer, but it's just a basic understanding how it works. So anything works on this layer will only do the operations. Let's say you have a hub switch, hub repeater. So it can only understand the prospect or parameters of these guys. Parameters only of these guys. We have a parameter here, MAC address. So we can say, okay, it understands layer 2 connectivity. So we have a parameter here. So we can say, okay, we understand layer 3. This is layer. So some firewalls only understand transport layer. We can say, okay, that's a layer 4 firewall. So they can stop and allow a traffic based on transport, right? So it's a backward compatible too. So if somebody can work on layer 4, that can work on layer 1 as well. That can understand layer 1 as well. So it's a backward thing. So if let's say this is data link layer, right? So it understands the physical connectivity as well and MAC address layer 2 as well. Is understand both of the part, right? Is anybody send me a text? Application, presentation, session, transport, network, data link. That's good. That's great. Application, presentation, and session. Sorry, the session is here. I'm sorry, just so much concept here. So presentation, and then you have a session here. So we can actually cut down a little bit. That's a presentation, and that's a session layer. So you have 7 layers. So right now we just not gonna touch that much, but it's just a basic understanding of what we're doing. But in upcoming videos we have a more very depth understanding of OSI layer. So we can start from the next part now. But any confusion so far? Anyone has any confusion? Anyone but has any confusion here? I can explain more if you want. Justin, Aditya, and Agent?
No, sir.
Okay. So you're good. Thank you. Okay, let's go for the next slide, what it does. And that's a switch operations. That's how a switch operates between the end users and how you see this only shared to intended person. So it may be understanding what this packet is only for this guy or only this guy. So just to make sure, every computer have every computer have what? Unique MAC address. That's true or no? Unique MAC address. That's true? Yes, no? Every computer has a unique MAC address?
Yes, sir.
Okay, that's great.
True.
Yeah, so every computer have a MAC address is unique. So that's why switch can only send to traffic that receive on the port. So what it does, it has some sort of MAC address table. Okay, it has some sort of MAC address table all the time. It always carry that table. So let's say whenever you connect a cable to this computer, it has some sort of operations keep going on. Some sort of operations right away. It keeps sending traffic to each other. It will ask you, hey, buddy, what's your MAC address? You're connected. You are the new person is connected. So it will send, hey, this is my MAC address right away. And it will store in this MAC address table. So then when somebody's connected here, so it will ask you, hey, what's your MAC address? It will store in the MAC address. So that's how the MAC address keep getting added to each other. And after that, and that MAC address is associated with what? With these interface, with this each interface. Each interface has their MAC address. So now any computer will send in traffic here. So it will know, okay, this traffic is for another MAC address, maybe this guy. So it will say, okay, what is this MAC address connected for? For this guy, or will send to this guy. So it's much better. It's a good practice, and that's how it works. That's how the switches works, and that's the best way to understand, I believe. So let's go for a more. Only detected device is physically connected. That's I told you last time. Can detect specific devices that are connected to it. Could be MAC by the MAC address, and keep a record of MAC address of those devices. We learned about it. That's good. And now we have a hub, switch, and router. So hubs and switches are used to exchange data within a local network. LAN network, local and area network is a LAN, same thing, not used to exchange data outside of their network. So it's only in their network they can exchange the data. You cannot send to another, let's say you have another branch, you cannot do there. Yeah, so to exchange data outside their own network, our device needs to be able to read IP address. Okay, that's great. We are going good. We are going good. That's where I wanted to show. Okay, that's cool. That's good. Okay, it's going to be more exciting now. So what I showed you in layer 1, that's good. Your OSI model being completed here too. So you have a layer 2, right? Layer 2 is what? For MAC address, where you can read the MAC address, right? Then you have a layer 3, which is primarily function of routing or router. This guy works on layer 3. So right now, let's say you have a switch. The switch or hub, both are the same thing, but are slightly different with one above layer, which is a MAC address added here. Let's say, yeah, switch or hub, both are the thing here. So you connect a network here. You connected and local network, which means you only can share. Let's say you have this branch, right? You have this branch. You have 5 offices here, 1, 2, 3, 4, and it has the same IP address of same subnet. I'll tell you in the next class. One is same subnet. /24, the same subnet, and you are on the same subnet, same network. So what will happen? Your switches only can exchange the data and exchange the traffic between this network. You cannot go outside of a network. You cannot go outside of network. Let's say there is another branch here. There is another branch here, right? You want to share traffic between them. How would you do that? You cannot do that. Either you put all switches, right? Let's say, let's keep it a little simple. I'm gonna put one, if I can, hopefully I can drag one small time for Atonate. Whiteboard. You can see any whiteboard here?
Yes, sir.
Okay. So what you really need to do here, understand here. So let's say you have one office. Yes. Okay. You still can see my whiteboard? Are you still seeing my whiteboard?
Yeah, we do.
Okay, great. So let's say you have branches here. You have branch here, one B1. You have a B2. You have a B3, right? So you have these branches here, right? Or you have office in one branch, you have two offices. Office 1, Office 1, and Office 2. And Office 2 is, slightly maybe like 100 meter ahead of each other. Let's say 100 meter,
Excuse me,
100.
is the whiteboard still empty from my side? I can see no branches, nothing. It's still just white.
You
Same,
can
same.
you can't see anything yet? Let me just
No,
It's just a
whiteboard.
whiteboard.
just a whiteboard. Okay.
Yeah,
Let me do another way to do that. Maybe just a small slight difference between.
that would be great.
It would be great. Okay, let's make it.
Thanks, Dr. David. Vibing naman.
Hey, Aditya, please mute yourself. Okay, so now you can see the branches. Now you can see the branches here.
Yes, sir.
Okay, B1,
Yes,
B,
we can.
this part, right? This part, right? Okay, that's great. That's good to know that you can see that now.
Thank you so much, Daddy.
So
So helping me, Daddy. Thank you. Oh.
Chaitanya. Okay, Chaitanya is off now. Okay, let's see here. There's another branch here. Then you have a Office 1, 2, 3 here. Office 1, Office 2 here. You have a bunch of offices, right? Then you have the same thing with this too. And you have a O1, O2, and bunch of it, right? So either way, if you don't have, let's say, either way, you have to do putting a switches here, everywhere, or hub into all branches. Keep doing it just to make LAN connectivity. So this office want to connect this office, this want to connect to this office. So you need so many switches, so many cables, so many switches, everybody. Then you will be able to connect to each other, right? On layer 2. So you become like a local network, right? Is a little bit understandable what I'm saying? You need some connectivity, right? To connect to each other.
Is
Right.
this branches on the
What,
same
sir?
area or?
No, it's different buildings. Even in the same building, even in the same building, let's say you're in the same building or in a different building, branches are in different building, maybe 100 meter apart, or maybe 1 kilometer apart, or 2 kilometer apart, could be. So what you need to do, how you connect to each other network, how you do that?
So many switches or VLAN.
Yeah. So you need something, right?
Yeah.
You need either a cables connected to each other, or you make a LAN network, right? You need to do something, or you just put a switches. You keep doing a switches, and do layer to traffic. So that will be a very bad practice. Would be a very bad thing to do. Like you will never do that. Let's go back to the same slide again, if I can move down. Okay, here. See here now. So what we do, we brought another thing. We brought some sort of stuff. We brought this guy, the router. We brought another thing. And this guy works on slightly different from layer 1 and 2. Layer, sorry. Then you have a layer. Then you have a layer 3. So see how this interconnected to each other. Hub only works on this layer. Switch works on this layer, even they are the same devices. And router works on this layer. So switch has the power of this guy. Switch has a power of this guy as well because it works on layer 2, but it works on layer 1 as well. And same with the router. Router has a power of layer 2 as well and layer 1 as well because you are connecting a cable as well here, right? So whatever the operation of hub and switch would have, router have the same operations, right? Router can read power cable as well, like just a normal cable as well, cable's property as well. MAC address as well, for sure, because it slightly works on a different layer 3. So if something can understand layer 4, if something can understand layer 4, they can understand layer 3 as well, layer 2 as well, layer 1 as well. They have to be understand that. So it will understand MAC address as well. It will understand a slightly above protocol, a higher protocol, which is layer 3, which is your network protocol, most important protocol in the world right now at the moment. Without that, there is no internet. If we didn't have the network protocol invented, IPv4 or IPv6, we never had any inventions. We never had any internet. We would go out of internet. How would we connect to each other? Through the IPs, through the network layer. That's what it does for us. And that's how router works. Now, let me show you a bit of how a router packet frame look like. Anyway, I wanted to show you more details in the next upcoming level. Let's just want a different packet. Just a small picture. Here. This is how it works. This is a TCP packet. Sorry, was actually IP packet. This is came the TCP, but the same thing. But I just want to make sure you understand more bit into it, understanding of. Anyway, we're gonna learn more about that IP, how it works and all. But just a very small introduction. It's just all introduction. Do not worry about that. We learned everything. Okay, guys. We're gonna learn it like maybe 10 times more. The same thing. So do not confuse that. Okay, you didn't understand today. So in the future, how? Okay, no. Future you have more understanding, more depth on that. So don't worry about that. Do not scared about that. Okay, so this is called version. Version could be now I have to change my color pen. Because it's a different version could be what? 4 or 6 could be IP versions, IP version 4 or IP version 6. Then we have packet length, how much packet you have generated. Let's say our computer can send 1500. Identification is a special number, like every packet has its identification number. It could be 12, 15, 20. It's keep carry on all the time. Then we have DF, M5, fragment offset. Time to live is a very important. Let's say time to live is a kind of more like how much a packet can travel from one router to another router. Then you have a transport. Then we have a header checksum. It's a pretty different thing. I'll explain you in the So let's go on the main goal. Sender IP address and destination IP address. So did you see on when we was talking about what? When we were talking about frame, like switch frame, did you see how a frame look like? No, you wouldn't see that, but sure, I'll show you here. Ethernet frame, we call it. See here. Now I'm gonna delete everything. Make sure I'm gonna start again from a scratch so you can understand both the parts very fairly, because otherwise it confuse you. So let's say here, how a switch standing in traffic based on source address and destination MAC address on layer 2, right? On layer 2, it was sending a traffic. I'm right or wrong?
Right, sir.
Right. Like we had some sort of unique MAC address which was listed on MAC address table, right? MAC address table, right? So you would go, okay, MAC address table is there, okay, so it will send traffic to the same MAC address person. Okay, this MAC address is 00001 or 0002. What are that MAC address? It will send to the same person, to the destination. Who's the destination? Same here. It's a slightly different that it understands a bit higher protocol, sender IP address and destination IP address. So it has what? Routing table. Every have their own table to understand. So switch understand MAC address table, and they keep a MAC address table all the time. They keep improving if there is a new device came to up, so it will update the table to the later to the latest one. Same as the routing. So routing table has a parameter of what? IP addresses. And IP addresses are unique as well. You cannot have duplicate IP addresses in the same network. And you cannot have a duplicate MAC address in the same network. You cannot do that mistake. That's a big breach. So let's say you understand that point, right? Pretty well. Is that or something I need to clear more?
Oh, it's okay. Now we are on layer 2. We are talking about the communication by MAC address. On layer
Yes.
3, we are communicating through the IP. Now it understands the IP through routing table.
Yes, that's great, buddy. Everybody, is anybody has any problem to understand? Yes, no, yes, no. In the chat, I can explain more. No? Okay, I'll move on and we'll put the next one. Okay, let's go to the next and you can next see the frame. So now you got a traffic, you got a traffic here, you got a traffic here, and it's just sending data here. Now you have end devices here, you have end devices on the router side too. And let's see what does it show you. What is that? That's the main portion of the gateways. So routers are being called at what? As a gateway. And gateway works on what? Layer 3. Layer 3. And layer 3, what is that? Layer 3 understand IP protocols. So now this device, when they send up frame or packet or application, any layer, it always make a full-fledged data. It's never sent just one thing. It sent you all layer 7 detail. Layer 7, 6, 5, 4, 3, 2, 1. It will send everything. It will send everything. It has one packet. This is what we call one packet. Packet can never become with these 3 or these 4. Packet always contain all these 7 layers details. Got my point, people? Everybody?
Yeah, so it always sends the whole packet.
Whole
and
packet.
Depend on which the next device, it will understand which layer.
Understand, boy. Okay, so now switch can understand a layer, so it will open this layer and it will send a traffic. Now router has a capability of understanding layer 3. So it will understand the layer 3 packet, and layer 3 can route more ahead of the local network. So layer 3 is more like a WAN. So when you have another router here, and router will understand, okay, where the packet came from, it will send to the local area network, and then local area network will send traffic back. So that's why you need a router. We will understand more deeper in the next classes, but that's a basic concept, basic operations. That's what the layer 3 and layer router works. Even if same class, you're clearing your layer OSI model too, but I'll explain more in the future. Let's say I can go forward now from here, guys. And that's the red network, right? This is a basic operation. Let me just go back. Please mute yourself, everybody. Do not leave yourself unmute when you are having a personal conversation at your home, so it disturb everybody, please. See here. Everybody being clear now here? So what is Dad's understanding now? Okay, let me explain you a bit in more detail here. So a router can connect it to multiple networks. That's true or no? Right? Can connect to so many networks, unlimited networks, or multiple networks. Same thing. It's true? Yes or no? In the chat.
What, sir? Sorry, I'm confused. What?
A router can connect to multiple network? A router can connect to multiple network?
Yeah.
Yes or no? Yes or no?
Yeah.
Right? Because
Yeah.
switch can connect to multiple computers, right, on layer 2. So it means router can connect to multiple networks on layer 3. That's pretty simple. Okay, that's great. Okay, so now what this picture is saying. So you have a one traffic of green, yellow, blue, this another yellow that's been trafficking. So a router will understand, okay, I got a traffic from this source to this MAC address. So this source is connected here, or maybe like not this, like you can say this cable is connected somewhere here. This cable is connected. It just show how this, but mostly you connect on the interface. This is called what? Interface. So now it will tell, okay, oh, red network is here. Maybe 192, whatever the network is here, or connected on here. So it's passing through, and it will redirect that traffic here on the basis of layer 3 information. Layer 3 information on the base of that. That's it. That's how router works. Clear? Any need to be redirected again? Any need to be repeat again? Anything need to be repeat again? Okay, Aditya, no problem.
No, this is fine for now.
Okay. Anything need to be repeat again? Justin, everybody? No? Can I move forward? Okay,
Yes,
let's go.
please.
Yeah, okay, great. So that's how it works. That's red network came, and red network has been. So this could be a blue network here, yellow network here, just as a hypothetically. You can say that it's a hypothetical network. It's not a real network, but in the future we will surely learn that too. Data rejected by a network sent to another network. Okay. Same here. So this is how a router works. This is how our real internet works. In our previous class, I have showed you that there was a picture of submarine cables. Remember, a submarine cables was all the way. We have connected everywhere in the world. Did you remember anything in the last class? That we have a submarine cable all the way in the worldwide map. I showed you live map. But anyway, you can go for okay, Chaitanya, remember? Great. So that's how our routers are everywhere in the world. You will see everywhere in the world, one router will be there somewhere for sure. Everywhere. You may have your house you're living, just beside your house, you will see one router there. And that understand layer 3 network. And that's why routers are really important. And we call routers as what? Gateways. That's the reason. That's the real property of router. You can say routers are gateways. Now let's go for next slide, if you can. See here, it's see here, now we are receiving a traffic from here in the red zone, in the yellow zone, in the green zone, in the blue zone. So router will understand, okay, the traffic is here. So every router has their own table. So what? Every router has their routing table. Routing table, please simple. So routing table means could be green. No, I'm just hypothetical saying it would not be a green table. Like it's saying, okay, green, yellow, or blue network, just hypothetically. It's mostly IPv4 networks. Mostly you would say 192, but for now, just for understanding a little bit, we can say just a blue, green, yellow. So Okay, so it's saying, okay, something came from red to yellow. So it will come from here. It will say, okay, I need to send to yellow. Or you want to send from yellow to green. So you can send, okay, the green connected on here. Or blue, where is the blue? So it has a table here, blue, and this guy has a information of blue has where. Okay, blue is on this side, so it will send to this router. So that's how a whole network is connected to each other, because we have our shared routing table. Shared routing table we have. Any problem to understand here so far? Almost our slides are gone.
And of course, if they are separate as internet, as you said, then we are talking now the unique IP will be the public IP, right?
Yes,
For
unique
each
will be
router.
public IP. So we will understand later what is public IP and public IP and so there are two type of IPs just for now. Two type of IPs. One is public, which is been for everybody. Everybody can see that. When there is private IP, it's only been private to what? LAN side. So LAN side has a private IP, right? And router has public IPs, most probably. It should have, but some people use LAN. If somebody have a big network, so they can use LAN. But most probably what you have, a router has a public IP or whatever's on the edge. So it is unique. So private IP will be what? Unique to LAN. Unique to LAN, public IP, private IP. Only here. So you can have a same IP here, same IP here, same IP here, if you over the internet you're talking about here. But these guys must have unique IPs. Must have unique IPs. Because we have something called NAT, right? NAT is like network address translation. So when IP, any packet goes off, so this, any packet travel from here, from this router to another router. So it will always, what we do, it has something called a translation here, which convert this IP to their public IP. And then everybody can see that IP. We will surely see that later, but in just a common sense, I'm telling you, in the just a common network. So do not confuse between. So LAN must have a unique IP and public IP must have unique IP. You cannot duplicate anything. You cannot. If you duplicate, it just go. You will just have a big problem if you duplicate anything. So let's wind up our class, and we have more in the upcoming. And that's all we have right now to say. Hub and switches are used to create networks, local networks. Router are used to connect networks. Okay. And
Okay.
and let's go to a slide back. So here we understand layer 2 switch. Then let's say we have a layer 3 switch as well. We will talk in the next class. And then we have a PoE or Ethernet switch. Then we have a stackable switch, web managed switch, smart switch, enterprise switch, industrial switch, data center switch, cloud managed switch. Then we have a campus switch. So we will learn this in next class as a small, maybe 10 minutes or 15 minutes I will take from you. Then after that, we will move to different concept. All right, guys? Everything all good now?
Great.
All
Yes,
right.
that's great. Can we share this schedule as well?
Yeah, share the
Next
schedule.
session?
Yeah,
Yes,
it's the same time.
Okay.
Same time. Every day with same time. Now we're gonna go more. Let's say I'm planning to make a 7-day classes from Monday to Saturday or Monday to Sunday. Like I'm planning to do that because I have an office time too. So what is that's why I was asking in the chat everybody, hey, what's your preferred